So I'd like now to launch our first model of the day, and we're going to address a limitation of yesterday's model. Yesterday's model enjoyed many virtues to recommend it, but one of the things it lacked was dynamics. It was a static model in the sense that we gave the population these interesting characteristics. We captured heterogeneity. We captured a visual representation that was quite rich. We could display the statistics associated with the population. Lots of good things going on, but there was no dynamics to speak of. It was static. We created the model, and it was a nice visual, but nothing changed. And this morning, we're going to remedy that. This morning, ladies and gentlemen, we will be imposing dynamics on a population. There'll be heterogeneity in state of that population, and people will evolve over time in their characteristics, okay? So I'd like you to close out whatever models that you have open, just so we don't get confused. This is another failure mode in AnyLogic. It's very common, or at least somewhat common. You have a person class open, but it's a person class from the wrong model, and you drag something into there you mean to be for model A, and you actually add it to model B, and that's not that helpful. So we're going to go and experiment with one way of representing evolution of agent state, namely with state charts here. Okay, so it's time to go through our basic bench presses and exercising our biceps. We're going to create a model from scratch and exercise the same basic features we undertook yesterday for a fair part of it. So I'd like you to add a model. How do I add a model in AnyLogic? How do I go add a new model? It stands before me, blank, as it will in your offices when you finish this boot camp. It's awaiting your command. How do I add a new model? File, new, good, excellent. File, new, model, okay? And I'm going to say simple agent state charts, North Carolina, okay? You don't have to say North Carolina. Okay, I am in North Carolina. You are of North Carolina, okay? So here, what stands before us is the default features of a model. We saw this yesterday. A main class is created, empty in terms of visual representation, and experiment is created. Okay, so ladies and gentlemen, I would like to go and I'd like to add a person class. How do I do that? How do I add a person class to our model? Okay, yeah, we could do right-click and new agent type. You can do it from palette and drag in an agent type, but I think I would recommend this, and I'm actually under familiar with this. I think there's a way to add a new agent type from there, but I think it's more consistent doing it this way. With other things that you add into the model, you go through the same exercise. So new agent type, and let's do person. And ladies and gentlemen, I'd like to just do finish here. You could say they're templates. You can use a template, and we'll do these things for you. But it's important to understand how to do things from ground up yourself, so that when something goes wrong, you know how to fix it more readily. So I'm going to say person, and I'm going to say finish. Person is in no way privileged. We could have a model with deer and people and dogs and all sorts of cars and all sorts of things in it. But given that the focus here is health and that we don't have many veterinary science students, in fact any, I think I'm going to be hewing mostly to persons in these models. Okay, so we've added a person. That's great. Suppose we want these people to have a representation that's maybe an oval. So how are we going to do that? Riddle me this. We want to give them a visual representation, have an appearance. We want to give them a face of sorts. How are we going to do that in our model? Okay, so we're going to go to the palette. That's great. My palette is down here now. But okay, so we go to the palette. What are we going to? So what are we going to add? Okay, it's presentation, and to what class are we going to add it? Main or person? To person, because we're adding a characteristic of a person. Okay, we're giving them an appearance. We're lending them a face. Each person is going to have that. It's part of being a person, part of personhood. Okay, so we've just done that, and I've made the thing smaller so you don't have so screen real estate can be used more efficiently. Okay, great. So we've given them a appearance, and now we wish to add that person to a population. Can anyone tell me where to go? So we've created personhood. Now we wish to add a population of people. Where do I go? Okay, good. Main. Yep. And we drag person over into here. Okay, when we drag it, what do we have to do to call it population and to make it a population? One thing, give it a name. And you could do that name either here, or if you were to leave it where it says person, you could do it down here in properties. You could do it either place, okay? That's fine too. But what's the other thing we have to do to make it really a population, not just a single agent? We have to do, this population of agents. And notice it says initial number of agents, okay? That's great. We'll say 100 agents. Okay. So what would happen if we ran this model right now? Well, let's do it. First of all, how do we check that the model, that AnyLogic knows what we mean by the model? We do this build button up here. We say build model, and it says build completed successfully. So now let's run it. And, what do we see? Is there a population of people here? Who needs TA help? The TA stands ready. Okay. All sectors are quiet. Okay. So let's go to this. Let's go explore the people in the population. Go to this navigation menu. If you don't see it, you can enable model navigation. And we could go through every person in the population, person 0, 1, 2, 3. There are 100 people in the population, but they're all on top of each other. 100 people, you notice that you could see this population of 100. It also indicates 100 people, and it'll start listing them for you. But there's very little differences, person 1, person 2, etc. Notice it starts at person 0, okay? Okay, we've got this model. We're off to a start, but we want to lend it a little bit of a visual appearance, so at least people appear at different places. So to rehearse, we created a new model. We added a new agent type to the model by right-clicking on that and adding new agent type called person. We dragged an oval into that, and then we created a population by dragging that into main class, and we set it to be a population of agents called population of size 100. But what do we need to do to have them appear at random locations on the screen? Can anyone remember from yesterday? I mentioned it earlier in my recap. Okay, yeah, so in main, we scroll down and we set their layout type to be random, okay? Okay, so it's in main. Main sets the appearance for the agents that live within it. And so here we have environment for other agents in the properties of main, and we'll set it to be random, okay? So let's run this now. And this is what we should see. Who needs TA help? The TA is scanning. No? Okay. So do you see something like that, folks? Okay. So that's great. And now what I'd like to do is to build on this. So all this is old territory from yesterday. I'd like to add a denouement to yesterday's presentation by actually doing something Yesterday we used parameters a lot, but we used parameters all at the level of the agent. How would we have it so that the population in Maine had a population that could be different, could be varied between experiments? Anyone? How do we have a population whose size could be different between experiments? So let's put a parameter in Maine. So double click on Maine to open up Maine. Let's go down Maine, and let's go up to the general properties, and let's go drag a parameter into Maine. Okay, and this parameter will be called population size. Naming things within AnyLogic is important. It's important to think about the names you choose. Names have a disproportionate impact on the transparency of a model. If you use a name that's clear, yourself, later, and other people who look at this model much better be able to understand what's going on. It will really materially lower the risk of making errors in many cases. So we added a parameter to Maine called population size. Now, how would we count the population? Is it in, like, would you use 32.38 people, or would it be something else? It will be an integer. It'll be an integer. So this population size is an integer. It's a count. It will be non-negative, but it's not a double precision value like pi, or 3.14159. It's an integer, 0, 1, 2, 3, 4, etc. for our purposes. Okay, so that's a population size parameter, and we're going to have a population size given by that parameter. So how do we do that? How would we have the population have a population size given by a parameter? Yeah, the initial number of agents put population size. Okay? Okay, great. That's good. And now who specifies the population size? So, by the way, what did I do? I went to population here and set the initial number of agents to be population size. Okay? Okay? And so where would that be specified now? So if we have a parameter that lives in an agent in person class, well, where is that specified? It's specified in Maine, particularly in the population in which those agents live. For a parameter in Maine, where is that specified? In the experiment. Yeah, it's the thing that creates it. So agents, a particular person, they're created by some population. So it has to tell them what to assume for particular values. What creates Maine is actually the experiment. So the experiment needs to be told it needs to tell Maine what to assume. So in the experiment, we'll now see something waiting for the population size, and we'll say 100. Does that make sense? Does that make sense? Okay. So let's just reflect on what we've done. So yesterday we added parameters to person, and the population needed to specify their values, things like income, sex, age. Here we've added a parameter to Maine, and the experiment needed to specify its value 100. Okay? It could specify different values. We could have one be a large population with size 1,000, what have you. Okay? Okay, great. That's good. So ladies and gentlemen, I'd like now to run this model. So I'll build, make sure it's happy. It's happy down here. And then I'd like you to try running it, okay? And you should see something like that. See something that's no different from before. Now let's add a large population. So how would I add a new experiment? Let's add an experiment, a scenario with a large population. How about one of the students this time? The student side is more quiet. So how would I add a new experiment, a new scenario? Oh, sorry? Right-click the simulation and do new what? Experiment, yeah. And let's say large population, okay? Let's add one for large population, and let's put a population size of 1,000. What do you think? Is that good or not? Okay. Okay, that's good. Okay, and now I'd like you to run it, and there we go. We should get something like that. Is that right? Okay. For those who came in, I'm going to really quickly go through, and Priya will be with you in just a minute here to help you. But briefly speaking, we created a new model. We went and we created a person class. We added an oval to the person class, and we then went to main, and by dragging in that person class into the main class, we added a population. We indicated it was a population by selecting population of agents. Initially, we had it at size 0. We then went to main, and we went down in this, in main, to be a random layout here, okay? A random layout down here in main. And we ran the model, and we saw something that looked like this. Then what we did is we added a parameter to main called population size, and we made population depend on that for its initial number of agents. And then we added a new population, which had a large population of 1,000, and for this population, we had to be a population of 100. Okay. So those are our two populations there. Okay, so here we just use parameters like we did yesterday, but there's still no model dynamics. Any questions about this? Priyasri is enjoying what we call in computer science a high duty cycle right now. And so any questions? Yes. Yes, I'm having a little trouble sure. Executing the large population. Okay, so let me come around. For this, and large population, that looks good. So, and if you run it, compile it, yeah, and running it just compiles it automatically. Right, it does. But it brings up the okay. Here, can I try? I think it's because the default when you click this button up at the top, the default one is just simulation. I'm sorry. So you have to either select that or you could run it down here. But if you select this, then you'll see that. Is that helpful? Okay. Great. Okay. So, any other questions? Yes. So when you run the experiment, yes. This square, yes. You want to make that square bigger? How can you do that? Yeah. So, in other words, when you're running them, you see this kind of frame around this, and you're saying, I think, like they're packed into this this area here. How would you make that larger? Okay, so let's go here. We're going to go impose, so that's an aspect of their space in which they're embedded. We're going to be having a specific discussion of that in the next day, but I'll give you the hint and we'll return to it in a fugue type fashion. We will enjoy a spiral approach where we'll talk about it a little bit right now and talk about it in more fulsome fashion later. So if you go to main, so main is responsible for maintaining the environment for those agents, their spatial embedding, and in fact, by default, for setting up their spatial and topological embedding, their placement in networks, whom is connected to whom. So if we go to main and we scroll down and we could see this environment for other agents, there's a thing that says width and height of the space. Do you see that? So if you wanted to, this will be not very important for the rest of you, but if you want to say, change that to 750, and then, again, I'd like to build it, just make it sure it's fine, and then do run, and now we have a vertical dimension of 750. I actually don't like that. I meant to do horizontal. Meant to do horizontal of 750, and I screwed up there. So we want to do the horizontal dimension, not the height, but the width. to be 750. So if you want to do that, you can do it there in main in that environment for other agents. It will show it like that. Is that helpful? Okay, very good. Okay, any other questions? Yes.
When you're creating a new experiment and you go to set population size parameters.
Yes,
Why is this a static parameter? Why can't you sample the initial population size from samples?
So in other words, why does it have to be a particular value there? First of all, I'm not. You're probably right that it is, but let's go see. So let's take the large population there, and here we can we say population size of 1,000, and you're probably right. I don't remember. Can I draw this uniform discrete? Can I draw it from a uniform discrete distribution between 1 and 1,000? My guess is it will probably not be happy, but it could be. No, it's perfectly happy. So we could sample it from there. And in this particular case, it drew 691 as the value. In general, though, for an experiment to be well defined, we'd like it to have a value. If you're going to run the model once, you're normally running it with defined assumptions. If you wish to run the model many, many times, sampling from distributions, you could do that, but that will be a type of experiment that we'll be talking about either tomorrow or the next day. So we could add an experiment that's a parameter variation experiment, and we could run the model many, many times, drawing values in a Monte Carlo fashion from distributions. Is that helpful? Typically, for a single experiment, we're seeking clarity on how the model behaves with different assumptions. We'll be doing so with some fixed assumptions so that we have a fixed reference point. And it's later we'd impose running the model many times with different assumptions. Okay? Okay, and great questions. Other questions?
Yes.
Yes.
There's a z-value there. Are we going to be able to exploit that at any point?
Yes. If you'd like to, I'd be glad to have some discussion, not right now, but later in terms of the three-dimensional support for AnyLogic. AnyLogic supports a very rich three-dimensional representation of a model. We've used it in some of our models, but there are some models where it's used a tremendous amount, and I'd be glad to try to have some discussion of it. Okay? Thank you. Anyone else have questions? These are great questions. Okay? Okay, so folks, time is passing. We've just been learning a little bit more about parameters here. What I'd like to do now then is to get into dynamics. So we want to impose some dynamics on this model. So we want person state to evolve over time. What's one mechanism for describing changing state that simultaneously allows us to delineate different states in which someone could be on the one hand and the evolution between those states? It's a what? A state chart. Good. So it's not the only mechanism. We could have stocks and flows. We could have custom update code. But state charts are particularly transparent, the sort of thing to which stakeholders can relate. They capture quite a rich set of different situations, particularly given the set of transitions available. So let's go and impose a state chart here, okay? So let's impose a state chart. The first thing we want to drag in, so we're dragging this into what? Into person. We want to describe person's evolutions over time. There's nothing privileged about that. We could drag a state chart into main if we wanted to describe the change of seasons or something like that. Priyasri and I hail from a city which exhibits a measure of seasonal variability. And if you wish to capture the different seasons in our fair province, a state chart would be a good mechanism. So let's, in this case though, we wish to measure individual variability, so we're going to be doing so in person. And let's copy in a new state chart entry point, and let's call it a weight state chart. Okay? W-E-I-G-H-T, state chart. Okay? Good. Okay. Now we wish to add our first state to the state chart. So to do that, let's drag in a state, and let's call it normal and underweight. Now, notice I'm using what's called camel case conventions here. AnyLogic is built atop of Java, and in Java, there's little tolerance for putting spaces in things. You basically have two options. You can put underbars. By underbar, I mean a little thing like this, or you can use camel case, where you put words that are different together by capitalizing the beginning of each word. Okay, and either is a fine convention. Underbars can get missed if you have an underline also together with it. So I tend to prefer camel case for these contexts, but you can pick your poison. So normal and underweight I've added as the name of this state, okay? Normal and underweight. And you'll notice that with that being underlined, you can drag it around here, okay? You could drag its name, but generally we leave it atop the state, okay? Okay. Next, I'd like you to draw in another state that's going to say overweight. Well, state here, it's going to say overweight, okay? And then I'd like you to drag in a state obese. Obese. Okay. You can move these around as long as they're selected if you want to position them more nicely. Okay, that's great. So ladies and gentlemen, we've just gone and we've added 3 states and we've named them. That's a great start. So how are we going to characterize transition? How are we going to characterize movement between these? Using a transition. Thank you. Cat out of the bag there. Okay, so we're going to go drag transition into here. Drag it so it goes from one place to another. And wow, I could just get it there. And let's drag 2 transitions. Okay? And now let's lend names to each of them. Here we're going to have a transition that will be called becoming overweight. Overweight. Okay. So I did this, becoming overweight. Maybe I'll make this, something like that. Becoming overweight. And we're going to make it a rate transition. Right now it's saying it's a timeout, and hence it shows it as a clock. And what that means is after exactly 1 time unit, we'll make the time unit year here, it'll go from normal to underweight to overweight. So let's make it a rate instead, okay? And perhaps we'll make it something like 5% per year, okay? So this rate, and this is the alpha associated with the rate, the chance per unit time of going. Alpha, this is continuous time. It's going to be drawn from the actual time is going to be drawn from an exponential distribution with this as the parameter, 105. So on average, they will remain in this state for how long? Those students from industrial engineering, you should know this. It's a good question to ask on a comprehensives or something. So if this has a rate parameter of 0.05, how long will they remain in the state on average? 20, yeah, 1 over 0.05, which would be 20 years in this case. And then for overweight to obese, let's associate that with a rate let's give it a name. Let's say becoming obese, okay? And let's give it a rate parameter of something like 0.05 0.1. Okay. This is not particularly privileged. Obviously, it's not a particularly great depiction of reality here. Okay. Yes. The first one was a rate with 0.05, and the second was a rate with 0.01. Oh, sorry, 0.1. Excuse me. Correct. No, 0.1. 0.1. I misspoke. Yeah. Yeah, it's 5%, 10%. Yeah. Okay. Okay, great. Now, first of all, for these, for clarity, for transparency, I'd like you to do show name for these so we can drag their name to the appropriate place. This will help enhance the clarity of the model and the interpretation of these transitions. For example, if you want to show this model to others, or you want to get clarity on the meaning of transitions, you might have many transitions going from normal to underweight to overweight associated with different causal pathways, and you want to delineate what the meaning of certain ones are. So how did I do that? I did show name, and then I just dragged them around. Okay, so that's a useful thing. You notice there's this ignore, which allows it to tell us don't put that into effect, essentially, and that's going to be sometimes useful if you have something incomplete, you want to temporarily disable it or what have you. Okay, so that's good, folks. So here we have our first little state chart built up. Let's build the model.
Wait, quick question.
Yes.
Just for the naming variables, I noticed that your state has capital letters.
Yeah.
Your rate, your transitions have lower.
Yeah. This is kind of a habit that I've fallen into. I mean, we give gravity. We lend gravity to our naming, and it's good to be consistent with a certain type of thing to name it consistently. So when you look at it, you have some understanding of what it is, and it can be useful when making use of these names elsewhere to have a very standard convention in place. And the convention that I've hewed to within my group is having these be capitalized and lowercase for transitions, so you can easily distinguish between them visually. So when you see a list of names presented associated with this, you immediately know which are likely to be states and which are likely to be transitions. We'll see some cases later where that might be useful to sort of be able to scan quickly for that. But there's nothing privileged about that convention. It's just having some convention can be good, and having a convention that distinguishes things that are often mixed together, so you can kind of, just by glancing at it, you know what type of thing it is. Is that helpful? Yeah. Okay. Other questions? Great questions. Okay, so let's build our model here. Build early, build often. Okay. If you're not going to run it, build it. If you're done with a logical unit of work, even if you're not going to go on and run it now, build it. It'll help you head off mistakes. You'll find the mistakes when you've done less work, so you'll know where the mistakes live much more quickly. Yes. Yes. Thank you. It was on my mind, but it slipped it. So time unit. I need to take that down here. Beautiful. I'm grateful, Shakiba. Yeah. Okay. So let's go change the time unit for the model. So let's click on the model as a whole here, and let's go and go click. The model time units are not minutes but years. Okay. Good. Okay. Okay. So that will be something which will sort of set us in a position to use years. Priyasri, could you take down for this model, just jot down the notes that we need to change the time unit as part of the steps, okay? We'll make sure it's in the exercise. I think it is, but okay. So we changed the time unit to be years. What that means is whenever we're measuring time in the model, by default, it will be in years. Now, AnyLogic provides a very nice mechanism which goes easily unnoticed for converting between time units automatically. One might even say automagically. Well, okay, not quite automagically, but it's very, very nice, and I'll see if I can weave that into here. Okay, so let's go now run the model. If it does build, we should be able to run it. And remember, the interface for running the model is actually your friend for exploring it and seeing if things are happening. So, for example, here, we're running the model, and we're seeing something we haven't seen before, which is we're seeing an aspect of the dynamic interface here. People's current state is shown. We saw that in the very first model. And then the next transition that will fire, and the time until that transition fires here is shown in blue. So we're about to come up to a transition here. Boom. They became obese, okay? And if you go from one person to the other, here it's possible that you'll encounter, there was someone who was on the threshold of obesity.
We're not seeing that time.
Statecharts not showing up when we run the model, we just get this circle.
Okay, and so you'll have to go down to here and navigate down to the level of a particular person, and this is the browser that allows you to browse different people. And here, that's what allows us to see the current time. You'll notice, by the way, it's incrementing the date over here as well. It's 2095, 2096. Time is continuing, empires rise and fall, and the model's still running. Okay? Okay. Okay. Yeah. Okay. Yeah, you might want to run it from the start to get back to people into a state where they're still changing. So Steve, it might be useful to stop it here and then run it again, and then you'll see people earlier in their lifespan before the trajectory is shown. Okay. Okay, so we're seeing some action, but you know, it's nice to not be able. It's nice to be able to kind of see visually some of these things too. So while we have our first little state chart here, we can obviously elaborate this. This is a very pessimistic, one might say, fatalistic sort of view of things. It is possible to lose obesity. Interventions would often be focused on nudging down someone's weight, and we could have those transitions without difficulty. Time is limited, so I want to use my time for things which will yield enhance understanding additionally. But one thing that I would like to do, maybe we'll add, just to sort of show it, we'll add a transition here from overweight to normal and underweight, and perhaps we'll make this a lost overweight transition, right? And we could obviously do this as in any number of different ways. One would be a rate transition, which could be a rate associated with say 0.025. So here we're doing a rate transition going back. You notice that all these transitions are associated with the same basic icon. So they're associated with the same icon of that indicates it's a rate. Okay. So that'd be one way to do it. Later, when we send messages, we could elaborate on this in various ways. But for now, that will be, well, okay, we'll add one more transition. This will show a point. We can have many transitions from a given state, from state A to state B, which have different semantics associated with them. This last one will be sent a message that's, weight intervention message. Okay, and this last one will be triggered based on a message, receipt of a message, and Right now, we'll only have one type of message, so we'll leave it unconditional. In general, we want to test the message, see what it says. Does it say you are infected, or does it say you will lose weight? In this case, we'll set it to be a message transition and have it be unconditional. Okay, message transition unconditional. Okay, who needs TA help here? TA help? Priesri is scanning, and okay, all sectors are stable. Okay, so ladies and gentlemen, what I'd like to do now is to run the model. And you should see now people going kind of back and forth between those first two states. This person is in that very first state. Okay, they switched, but they're going to be losing weight later. Oh, no, they're going to be becoming obese. Notice that it's sort of, it's for these rate transitions, it anticipates which of them will go next. This person will be becoming obese is the next transition. And yet some people should be going back and forth between these first two transitions here. They may go from one to the other and back and forth. So that's great. It's interesting. But let's have their appearance be changed based on this transition. Okay, so based on their current state. Let's have their visual appearance be different. And we're going to do something. Yesterday we had visual appearance be set by aspects of parameters, aspects of heterogeneity. We're going to set it now by according to their state. So there's many ways we can do this in AnyLogic. I'm going to show you one way. Okay. So ladies and gentlemen, I'd like to make sure person is open, and I'd like to add a variable to person that's going to encode their color. Okay. This is going to be the color with which they're depicted. This is going to be an aspect of plumbing. It's not that important from a domain perspective. It's just a little bit of a detail from the perspective of making things happen. And correspondingly, I might be a variable that I want to hide off to the side so that when a stakeholder's looking at this, they don't say, "What's that color thing?" You know, because it's just an aspect of how we're going to accomplish this. So this is going to indicate what color to use for them, okay? Now this color variable is going to encode at a given time for a given person, ladies and gentlemen. It's going to encode a particular value of a color. It's going to be red, or it's going to be green, or it's going to be yellow, and yet it's associated with a type. When we have an income, we say it's a type double, meaning it's drawn from double precision values. It's one of the double precision values. If we add sex as a parameter, we'd say its type is capital SEX because it's drawn from the possible values of capital SEX, male and female. In this case, the value of color is going to be drawn from the possible values of something called color with a capital C. Note the naming convention. So the type is going to be other, and we're going to actually write out here color. It's going to be drawn from the possible values of color with a capital C, okay? So a given person is going to have a specific value, like they had a specific income that was a double, a specific sex that was drawn from capital SEXs. Here is going to have a specific color drawn from a capital C color, which denotes colorness or colorhood, the set of possible colors. Does that make sense? And we're going to make their initial color black. Okay, and you could call it all lowercase or all uppercase. It accepts both. It knows about both names for this color. It's nothing to do with Java. It's just the capital C color class defines both as the same thing. Okay. You can't mix the capital B, lowercase l. All uppercase or all lowercase. Okay? Does that make sense? Okay. And now I'd like you to, now we want to make it so that, okay, that's a nice thing. We call it color. It's a color variable. Great. All well and good. But how are we going to actually make their color be that color when we show them? Where do we have to go to set their appearance in AnyLogic? Yeah, the presentation. It's that oval up there, and It's that we want to go look at. And specifically in the oval, remember, we saw it yesterday. What do we have to set the oval color here? Yeah, the fill color. And we can't simply put it in here. We have to click this little thing that says equals to make it a dynamic value. And it's that little thing there. So we want to call it color. Okay? No capital, lowercase. No, because it's going to be a particular color. We have to tell it the fill color is this specific color. And it's a specific color associated with the agent. Capital C color is a set of all possible colors, and that wouldn't be that helpful. It would say, "Oh, I don't know what to do with that." It'll be kind of as if an artist said, "What color shall I use for this rabbit?" And you gave him like the whole palette. You said, "Use these." Use all of these. And they say, I don't know what that means. So this has to be lowercase c, the particular color. Okay, ladies and gentlemen, build early, build often. Okay? Again, the more frequently you build, the faster you will find a possible mistake, something where AnyLogic says, I don't know what you mean by that, and therefore the less work you will have done, and therefore the fewer places that mistake could live. It'll let you sleuth down where that mistake lives much faster. If you batch up a whole bunch of changes over a course of an hour, and then you press build, you got all these different problems, you don't know where they live, you've done all these different work, what's wrong? So build early, build often, okay? Okay, so let's run the model now. And you should see, what should we see? Anyone? All black. Okay, that's great. Well, it's a good start. It's a good start. We changed something, right? They're all black now. Okay, who needs TA help? Okay? Okay, great. Okay, so now, ladies and gentlemen, we want the color to change as they go from one state to the other. How are we going to do that? Well, associated with each state is what's called an entry action and an exit action. So when they come into that state, we can undertake some action. We can do something. We can tell it, do this. And to tell Java to do this, we use a Java statement. We say, do this thing. And statements are followed, as I indicated to Maria yesterday, followed by a semicolon. Okay, so we have to keep that in mind. What are we going to do to sort of make their color? Well, first of all, let's set their fill color associated with this, just visually with the state chart. Let's set that to be green. And then let's make it happen, okay? It's called lime. Let's set their actual visual color for the oval to be lime, okay? Fortunately, AnyLogic doesn't make this automatic. So what do we have to do? For those who know a little bit of programming, what do you do if we want to change the value of their color variable? What do we do? Set the variable to be equal to that color, okay? So what's the logic here? The logic is this little oval was set to use the color from that variable. It was set to draw its color from whatever this variable has as its color. It says, you got it. That will be my color for the circle. So what we have to do is modify the variable, and automatically the circle will become the right color. Okay? It will know to change. That's the idea. Okay, overweight. Let's make it a color of yellow. Okay, nice color of yellow. I think that's already its color, but let's make it, and then we'll set color to be what? Tell me what to type. Color equals yellow. Okay. Okay. Okay, fine. And then obese, let's set its color to be red. And tell me what to type. Color equals red. Okay? Okay, so here we're sort of telling it, hey, set this color to be red. Notice yesterday when we were testing whether color was equal to, if we wanted to test whether color was equal to red, if we want to ask, is color red, we'd use double equals. But here we're saying make color red. and it's a statement. It says, do this thing, so we need a semicolon after it. If we were just computing a value, is color red equals, we don't need a semicolon. That's just determining a value. It's like a formula in Excel. There's no semicolon needed. It's really when we're telling it, do this, we need that semicolon, okay? So build early, build often. Build is your friend. I would suggest building after you make each of those statements just to sort of see, okay? Okay, happy. Okay, shall we run it? Okay, who needs help? Who's not happy? Okay, so let's run this, and we should see people. So what's going on there? Anyone? What are we seeing? Okay, yeah. So out black spot. The black spots were disappeared and have been replaced by color, right? And now we see this color reflective of the state of the underlying agent. So if a person's color is normal and underweight, they remain green. If a person's state is overweight, they remain yellow, and if a person's state is obese, they're green. Okay. And over time, we see more and more obese cases because it's an absorbing state. There's no escape from it in this particular model. I don't particularly like that, and so maybe we'll add one more transition just to kind of to capture that transition out of obesity, and we'll associate that with a rate of 0.05, something like that. Okay. So that's good. Yes, thank you very much. That's a very important thing, and we want to show its name too. So losing obesity, and let's show its name. Okay. Now for these guys here, I'd like to show their name as well: lost overweight and then weight intervention as well. Okay, that's great. So we can run it again. Okay, and we can see this changing over time, right? Okay, that's great. Good. So that's suitable. Now we don't see nearly as kind of concerning a pattern. Instead, people are changing over time between these states, and at any one time, let's pause it, we'll see a mixture of states in which people are located. It's not simply going to an obese state. Okay, so that's good. Here we have a little state chart. Question? Yes.
Is it possible to isolate the conditions which lead to the translation?
Sure. In fact, we've left open the door to doing exactly that. So one thing is we've had this weight transition. Another thing is, this weight transition, which is based on a message. And moreover, you'll notice that in terms of some of the others, you can actually have a condition, for example, under which a transition is triggered. You can also trigger a transition based on, say, arrival at a destination. We'll be seeing that in the next day or so. So there's a set of conditions which can be specified for triggering things, and the condition transition I would note is particularly notable, as is the message transition. So you can send someone a message. Okay. So this is helpful. Yes.
How do you use the action field that you have in transition?
Because
you have the exit
sure.
in a state. So
sorry.
When you have a state, you have an exit
Yep.
option that you can go there.
That's right.
But when you have the transition, immediately after the state, you have an action as well.
That's correct. Yeah.
So how do you use that?
Okay. So basically, it provides you different means with different scopes of specifying actions to be undertaken. So this exit action for the entire state, that will say whatever, regardless of what transition you leave on, undertake this action when you leave this state. For a particular transition, it will specify the action we take if that specific transition is fired. So, for example, here, if we had an exit action, we printed something out, that would occur if we left this transition, or this transition. Is that helpful? So it could be more specific or less specific.
You have more than one transition.
Yeah. That's right. Yep, that's right. That's right. So for example, folks, let's have people report when they lost obesity. So when they lost the obesity here, under the action, let's have them say, I lost obesity, okay? So I lost my obesity. So we could do trace ln associated with this action, okay? And I'm going to actually print my name. I'm going to print the name of this agent. And the name is going to be this. That's my name. Okay, that's sort of my reference to me. And when I print it out, it'll be my name. Lost obesity. Okay. So the first time we're using this, but it won't be the last time. So trace ln. Let me put this up on the big screen. Okay. There we are. Trace ln. Begin paren. This is an L, not a 1. Begin paren this plus lost obesity. Java is really it doesn't care about how many spaces are there. You don't need it. You could have 0 or 1. It'll recognize. But I like to give space to give it greater transparency, greater clarity. You could read it. Yeah, sure. Let's do that. That's a great idea. So let's do this. So at time, we could say at time, maybe here at time, and then do plus and then time like that. And let me see if I can shrink this down a little bit. Sorry, it's a bit large here. There we go. Boom. There we go. Yeah. Okay. And I'll copy this down to here. Okay. Lost obesity at time. Is that helpful? Yeah. Okay. So this time we're asking, what's the current time? This is a function. It's like calling sine of 30 degrees. We use these parentheses to indicate, okay, call this function. Yeah.
So if you wanted to a trace of the first one,
yep.
Is there already an automatic option for that, or do you have to write a specific
to keep for a given agent? You're asking a question that's close to my heart. And one of the people who's going to be most instrumental in making a general tool for that is standing behind you on monitoring the things. But so there's two movements afoot to make this readily accessible. AnyLogic's also interested in incorporating what is called a bio-browser in ModGen to inspect the longitudinal state of an individual. And we do have some existing tools which simplify that some. One of the example models I've given you gives an example of how to do this, how to record successive history occurrences for a given individual. But suffice it to say that I think there's lots to do to make it easier. And I'd be glad to talk with you about some of the various options we have right now. But Priesri has a tool that she'll present later in the class, which uses a mechanism that we can also use to collect individual at a basic level. And in fact, Priesri's existing tool would do that, I think, because you could put into Excel and then you could do filter by, and you could probably filter according to, remind me, does it output the agent number right now?
It can output the agent number as
Yeah.
it does actually.
Okay.
Right now it does.
So she can do it for you.
Participant number it does
Yeah.
provide it.
Great. And she can do it for you without you writing any code. That's the amazing thing.
Right now it writes in a text file, but you can create in the CSV format and you can transfer it.
Yeah. Yeah. And you don't have to write any code to get it. It will just sort of look at your model and invoke and automatically instrument your model to do it. Yeah. So okay, so folks, I'm just running this model, and this is what we should see something along these lines. So I'm going to speed this up, and you could see these various reports. So and so lost obesity at time 31, etc. Right. So the question that Maria asked is a very important one for agent-based modeling, because a potent motivation for that sort of modeling is the ability to trace longitudinal paths of individuals. That's not something that's given by a cross-sectional depiction, such as you'll see in a system dynamics model. And it's important. Often we have data at a longitudinal level, and we wish to compare it against data generated by the model. And an agent-based model is very well suited to that because you can capture these trajectories of individuals. We also know there's path dependence at an individual level. Early life insults can lead to very different later trajectories on the part of an individual. And so being able to track those individual trajectories is important for model validation, for calibrating a model to historic data, for understanding the dynamics of what's going on in the model. So it's a great question. And let's say for that, you're asking a question that's actually it's one of the things I was considering adding to this. Maybe what we'll do is we will maybe we'll add a variable in here that will be count of times count of overweight, count of occurrences of overweight, something like that. Count of occurrences of overweight. So we're going to add a variable to the model. We've used color. Now we're going to add a variable. It's a count, so it's an integer variable. Its values are drawn from integers. It can be 0, 1, 2, etc. Count of occurrences of overweight, and we'll make its initial value 0. Okay? And we're going to, how would we, ladies and gentlemen, if we want to count the number of times that someone has been in a sort of situation where they're overweight, putting aside the issue of how long they're in that, which is very readily done as well, but it involves a little bit more finesse. How would we record the number of times they've been overweight? Where might we change that? Okay, so initially it's 0, suppose, because they all start normal and underweight. Suppose we wanted now to increment it by 1 every time they've been in the state for some period of time. Where might we do that? The entry action for overweight, we could say count of occurrences of overweight. Now, we could say count of occurrences of overweight equals count of occurrences of overweight plus 1. That's a kind of long-winded way to say it from a Java perspective. Among other things, to kind of look at it, visually, it's not obvious this is the same as that one. So you got to kind of look, oh yeah, we're making this be its own value plus 1. So we tend to hew to a more compact way to say that communicates that we're just incrementing it. We use this plus plus. That basically says make it 1 bigger than it currently is, and it makes it clear we're modifying this. We're making it 1 bigger than it currently is. Okay, it just changes it by 1, ups it by 1. So every time we come in here, we're gonna chord it to be 1 larger. Okay? So that's kind of nice. Let's build it. That's good. And let's run it, okay? Let's go run this thing. And we'll go down to level of an agent, and we'll see this agent has never become overweight. We'll go down to an agent which is overweight. Okay. So they've had one occurrence. Over time, they've had 2 occurrences, 3 occurrences, 5, 7, etc. So in case you folks didn't get it, I put that in overweight, and it was whatever the name of the variable is that I created earlier. It's count occurrences of overweight. This variable started at 0, be sure, and it's count of occurrences of overweight. Okay? Okay? Yes, Kristen.
So the first time I accidentally created the variable in main instead of person.
Right. So you could cut and then paste?
Yeah.
Yeah. Mm-hmm.
But it occurred to me that a difference is do you want to count the number of instances within a person
right.
or overall in the whole population? Is that?
That's correct, but we could actually have it total it up for us over the whole population with a statistic.
How would you do that?
Okay, let's do that. Okay, so let's make sure everyone's synced up to this one. And I'd like to do, and then we'll do it with a statistic, and then we'll do one more thing here. Okay. Okay, and then we'll have a bathroom break. Okay. Okay. So people need TA help. TA help? So what we're doing is we're totaling up occurrences at an individual level of how many people have had different occurrences of overweight. That's interesting. Let's go up to the main class. Ladies and gentlemen, if I wanted to compute a statistic across the whole population, where would I do it? Okay, in main. Good. And where in main do we compute statistics on a population? Go to population. Okay. Good. And then let's do add statistics. Okay. And then let's have it be total, let's call it cumulative occurrences of overweight, right? Overweight, okay? Okay, so we're going to population. Wow, listen to those keys. Okay. And ladies and gentlemen, is this going to be a count of people that match some condition, a sum, an average, a min, or a max? It's going to be a sum. And over what is it going to sum? You just see the sigma there. Over what is it going to sum? What is it going to total up? Yeah, exactly. It's going to total up item.count of occurrences of overweight, and it's going to do it for everyone in the population. So we'll just say for true. Okay? Okay. So here we've done it for the entire population by summing up the individual level occurrences. Okay? Yeah. Okay. So let's go now run this thing. And where can we go to see the statistic? We could dive down to the individual level to see the individual level statistics. That's great. But where do we see the population level statistic? Yeah, it's in the population. Cumulative occurrences of overweight, 78, 79, 81, 80, 84. And this is something which gets updated over time. Okay? Sure. Do you want to do that? Yeah. Okay. Ladies and gentlemen, we had a request. Could we make it show in a nicer way? Okay. Should we go at a graph of it? Okay. So, ladies and gentlemen, go to main. We've had a request for a graph. And in the palette window, I'd like you to go down to analysis. And we're going to create a time plot. Okay? And I'd suggest putting this up above the sort of area here so that it's not obscuring the view of the agents. So I dragged in a time plot. Who needs TA help here? Okay. TA help? Okay. This is going to be a time plot, and this is going to plot cumulative occurrences of overweight, something like that, okay? And we're going to add a data item. The name of plot is not terribly material. I wouldn't worry about it. We're going to add a data item. We're going to give it a title like cumulative occurrences of overweight, okay? And its value is going to be what? Well, we're going to want to use that statistic in the population, okay? Now, when we define a population statistic, we can make use of it by calling population dot and then the name of the statistic, cumulative occurrences of overweight. So that's what we want. And notice I'm using my friend, the autocomplete key. So I could say pop control space population. I could say CU control space cumulative occurrences of overweight, and it will fill it out for me. Okay? Yeah. Yes, it's a function. So statistics are functions. So you call them and they'll do their job. They'll call them and they'll report it. And this is important because you don't want statistics necessarily to be computed willy-nilly all the time because they take some time to compute, right? And so they will be invoked if you call them, and then if you also call up that visual depiction where you click on the population, they'll also be invoked over time in that case. But otherwise, they won't be invoked. Okay? No semicolon, because it's like a formula. It's computing a value. It's not telling it to do. It's not telling it to change this, change color, do this thing. Instead, it's just computing a value like a formula in Excel would.
Okay.
You know, 3 plus 4. It doesn't need a semicolon for that. It's just calculating a value to be used. It's so-called expression rather than a statement for those who are familiar with the lingo. The function actually. That's interesting. How it's defined. Maybe you're right. Maybe it does. Oh yeah, it calls it a double. Yeah, I guess by default they return double precision values, but in this case it doesn't hurt that it's displaying it. Yeah, because any integer can be rendered as a double. Okay, so ladies and gentlemen, build early, build often. Okay, and now let's run it. Okay, we should see something like this. If you drag that up, you should see something like this where it's rising, right? And this is cumulative number of occurrences, so it's cumulative to this point. So it's going to continue rising as long as there's any new ones occurring, right? Okay. So those are the cumulative occurrences of overweight. Okay? Is that helpful? Yeah. Okay. Who needs TA help? Okay. The final thing we're just going to do is we'll go down to the person level, and we'll make a particular person's size depend on their cumulative occurrences of overweight. Okay. So we'll click on this oval, and we'll make their radius be that. Now I'm gonna deliberately do something wrong here, and you can tell me what's wrong. Learning how to sort of recover from errors is important. Okay, we're going to go down to the oval. We're going to go down, scroll down, position and size, and I'm going to type count. And note, it's saying invalid number. What's going wrong here? You have to change it to dynamic value. It's not going to be happy for that. You have to change it to this dynamic value. Right now, it's sort of some fixed value, but we need to change it to this. And now we could say, let's make it 5 plus count of occurrences of overweight. Okay, so in other words, it's going to be some minimum size, and then it's going to be a larger size based. Let's make it 5 plus 5 times count of occurrences of overweight. So for each successive occurrence of overweight, it's going to make it 5 larger. Okay, So I put up this formula, and there we go. Okay, 5 plus 5 times occurrences of overweight. Okay. Okay. So it's like that. This kind of occurrences is this one we've computed, and again, this is at an individual level. Okay. Here we go. So it's this guy here. Okay. Okay. Who needs TA help? Okay. Let's run this thing. So now we get a sense of variability in the population. Why are people growing over time? Eh? Why are people getting larger over time? They have more and more of a history of occurrences of overweight to this point. Their cumulative history of overweight is growing larger and larger. Okay. This is important. Sometimes it can be quite useful to be able to display visually things that are history properties of a person, not just their current state, but their history. Okay. I think we'll take a bathroom break because this will be our first, and then we'll reconvene in another 5 or so minutes, and just go say reconvene at 11. So it'll be about 8 minutes, and we'll then finish up the hour with a state chart that will interact with this one. We'll see how to make 2 different state charts and make them interact together so that one serves as a risk factor for another. Okay? Very good. Thank you very much.